is Mr. Ng going over the Math 5A quiz number 5 taken on October 29, 2019. Question number 1. If you use x cubed as a reference graph, so that's your parent graph, describe how you would graph y equals x plus 3 cubed minus 4. So here, you should notice from here to here, this is the parent-child function. Something's happening here, so you can do something like this. A value, f stands for your function, b parentheses x minus c, and then you have some kind of exponent, and then plus d. So you should recognize that d is equal to a negative 4, and when d is less than 0, that would be a, you're going down 4 units. So it's going to be either A or B. Now this one has down, so that would be incorrect. So none of these two. Now this has a plus sign, so I'm going to change that plus sign to a x minus negative c, or negative 3, sorry. So you can see that, oh, circle the wrong thing. Let's try this pen that I need to find. Let's try this one. That means your c value should have been a, because you have to have this minus sign. So c is equal to negative 3. And then if you have a c value that's less than 3, this is left 3 units. So your other choice is A. I'll have a silly phrase that can help you, and then you can try to use this. Add 2x, go west. Add 2y, go high. All right, let me show you guys how that uses that. Add to x, so here in this example, it's like a mnemonic that kind of helps you, or it rhymes, I don't know how to say that, but adding to x, add 3 means you go west, which is left. So in this case, you're adding 3, you're going to go left 3 units. Add to y, so this was like plus. So the reason why they call it adding to y, if you put your finger all over that, you just have the constant, so plus 4 to y. This would be, if that was a plus sign, add to y, go high or up. That's the trick. So, and not adding 4, so you're subtracting 4, so it's going down. Which function below is an odd function? So there's a couple ways you can do this problem. You can do this algebraically, and this was a star. You're going to put in sub negative x for x. So you can do that for every problem. And it wants to know what it is odd. Remember, odds are going to be the opposite of the original. Opposites of the original. So if I put them in there, negative x squared becomes 2x squared minus 8x. This is the original. So this would be even. So this one is not the answer because this is even. If I put into the 4th power, it looks like it'll do the same thing, but let's go ahead and try it. 3 to the negative x, 4th power plus 5 times negative x squared. So exponents first. Remember, you can use, if you need help, you can use PEMDAS. So exponents first, negative x to the 4th power, negative x times negative x, negative x, negative x, x to the 4th, so this becomes 3x to the 4th. This is x squared times 5 is 5x squared. So you get back to the original, same thing, even. Okay, this looks promising. This one has x cubed, that's x cubed plus x squared, so let's put in that one. And then here, this would become negative x times negative x times negative x, which is negative x cubed, and this would become a positive x squared. So if you factor out a negative 1, I get x cubed minus x squared. This is not the opposite of the original, so this A would not be the answer. This would be a neither. And I already know the answer is B, not by just simply saying that A, C, and D are wrong, but let's go ahead and put that in. 4 times negative x cubed, so every x value, I'm putting in negative x. This becomes negative x cubed times 4, which is negative 4x cubed minus 2x. And if I factor out a negative 1, I get a 4x cubed plus 2x. So inside you have the original, so this is opposite of the original, that is odd. So 2 is B. Question number 3. So the first thing you should recognize is that this is in descending order. How do you know what descending order is? You just go by the exponent. So you don't go in the number in front of it to the left, you're going to the number to the right, upper right. So 3, 2, 1, and then that's x0. So this is a odd degree. And the easiest odd degree that you know is x to the first. And it's a line that starts down, ends up. So these arrows here is called the end behavior. Let's write that, end behavior. End behavior. So essentially all I have to do is just look at all of these arrows here. Look at how the graph is ending. Now, another topic that I need to make sure that I have is the leading coefficient. So that's this, what's in front of the x? What's leading in front of this coefficient? What's in front? Leading coefficient. So that number is positive, which means that it doesn't do anything to the super easy graph. So we're going to start down, end up. And the only graph that's starting down and ending up is choice C, this graph right here. Starts down, ends up. And that's why the answer is C for 3. Number 4. Okay, now we have the sentence for end behavior. Identify the end behavior of the polynomial function. So look at these arrows. And this is your x, and this is your y. Another way of saying y is f of x. And the numbers on the x-axis going to the right are positive numbers, and if they're going to the left, they are negative numbers. Going down is negative, and then here it is positive. Okay, so this graph, let's just write my own sentence, and then that can help you understand. As x approaches blank, f of x, and then we can just match ours with the answer. Remember this little yellow box we kept drawing in class? This is always the same. You will always have one positive and one negative. Well, if you think about it, on the x-axis, it's always going left or right. So if I go towards the positive, that means you're going towards the right. And this one says, as x approaches negative infinity, says you're coming from this direction, what's happening? That means you're going towards the left. So as I go towards the right, the question is, what happens on the roller coaster? So let's just say you're on the roller coaster and you're just going where the graph is. You're going up. You're finishing up on the y values. That's positive infinity. So another way of saying this little last sentence, f of x, or the y's are just up or down. So f of x, let's just say we go towards the left. What's happening to the graph? I'm going to the left, which is negative numbers. What happens on the f of x? F of x is approaching, going down, negative infinity. So this would be going down. And this should be giving you a hint. This is a odd degree polynomial, so these two should be different. And now in this problem, they have the letter y. So it can be a little tricky. So we're looking for a positive infinity. Meets that one right there. And then I have negative to negative, so not that one. So positive, nope. Negative, nope. Positive. There's negative, positive. That I think is choice C. Negative, positive. So that one, not that one. So definitely go through all of yours. And then let's see, question number 2 is 4, 2, 4, 6, 8, and then with 10. So free response is 8. Sorry, multiple choice is 8, and then name and period is 2 points. Okay, the back side says use reference points in Symmetry to complete the table of values. So we have this function here. Not quite sure what it is. There it is. Tells you. Now let's use our highlighter. M of x equals x to the 4th power, and there's my m. So it's telling me what it is. And then it says p of x, so let's call this the child function. All you have to do is x minus 1. So this one right here, remember, if you had to write it, it is a times the function b times x minus c plus d. And so my c value, that's a c, let's make that clear. My c value is 1. C equals 1. And what we have to do here is create a rule. And if you use your formula sheet, you'll recognize that the c values affect the x-coordinates. They affect the x-coordinates. Remember, the formula is 1 over b x plus c ay plus d. Sorry, that's a minus sign. So whatever our c value is, we're going to subtract it. So we're going to have to subtract 1. What does that mean? All of my y coordinates are exactly the same. So let's put those 0, 1, 16. And so all of my x coordinates, so x, y, take that back. That was right, plus c. And the reason why I'm thinking about that is I'm thinking about my trick, add to x, go west or left, but we don't have an adding. You're going to go to the right, so you're going to add to your c values. So in this case, we're going to add 1 to all of our x values. So 0 plus 1 is 1. 1 plus 1 is 2, and 2 plus 1 is 3. So these are all of my new coordinates. Let's go ahead and graph these. Let's graph those. So 1, 0, right 2, up 1. Now if I look at my graph, they're counting by 2, so 2, 4. Let's see if I can zoom in a little bit more. So I'm going to have to go right 2, up 1, right to the 2, up 1, and then right 3, 16, right 3, up 16. Okay, so what do I need to do? I'm just going to do the same thing. Instead of going right 1, so this is 1, 0. Instead of going from the origin, so in some ways, all we did is just move every point to the right. That's one way of seeing it. So let's do that. Over here, and just shifting it over, and then you can kind of see our graph. It's moved over from the yellow to this brown or purplish color. So all the y coordinates stay the same, but the x values just change. Let's make sure we did use reference points and symmetry to complete the table of values. We did that. We'll come back out here, then graph the function on the coordinate plane, which we did there, and state whether this new function, is it odd, even, or neither. The answer is neither when you do a translation, meaning to the left or to the right. Although it looks like you can fold it on the y-axis, it's not anymore. Question number 6. Show your work and box your answers. It says to multiply. There's the multiplying right here. So I'm going to have my box. And how do I know to draw this box? I have 1, 2, 1, 2, 3. So 2 times 3 gives me 6. So x minus 4, x squared plus 2x minus 3. So then we just multiply first, and then we're going to add x to the third, 2x squared, negative 3x. Multiply those two, negative 4x squared, negative 8x, and positive 12. So we multiplied first, and then now we're going to add or combine like terms. So this would give me x to the third, and I like to put little check marks here to show that I've touched the box. Here we're combining like terms, so you're just looking at the numbers in front. So negative 4 plus 2 gives me negative 2x squared. Again, look at the numbers in front. Negative 8 minus 3 is a negative 11x, and then positive 12. Question number 7, you have a can here. Fill in the blanks so each row and column contain all the numbers 1 through 4. Numbers in cages may repeat, so the cages are the darkened areas, as long as they are not in the same row or column. So I'm going to look for any freebies here. I notice that 4 and 1 have no math symbols, which is great. So those are my freebies. And I need to think of two numbers here that add up to be 5. I'll be guessing at this point, 2 or 3 or 3 and 1. I can use 4 and 1, but I can't use because I already have a 1 here. So let's try this one. Two numbers that multiply to be 4. They can't be 2 and 2 because it would be repeating numbers here. So it has to be 4 and 1, and I can't put a 4 here because it's repeating. So I'm going to have to put 1 and then a 4. So this gives us an idea. Two numbers that add up to 3 are 1 and 2. Remember, you can only use the numbers 1 to 4. So that would have to be like 1 and 2, but that's repeating. So then a 1 and a 2. That means I'm missing a 3 here. And like we said, that number has to be 2. And we're missing a 4. And we're missing a 3. So we're definitely moving along now. Two numbers that subtract to be 1. I can't be a 4 because I have a 4 here. So this would be a 2. And then the missing number in the column is a 1. I need 3 numbers that add up to be 6, and if you subtract 1, that means these have to be 5, but this cannot be a 2, so I have 2 and 3. Therefore, this says the number is a 4, and then that has to be a 3. That equals 11. 6 subtracts to be 1. Freebie multiplies to be 4. Product adds to be 3. Adds to be 5, and the freebie 1. All right, question number 8. Here we are. Analyze the graphs of f and g of x. So this is f of x, and there's g of x, and there's f of x. So we're starting here, ending here. Write an equation in terms of, for g of x in terms of f of x. So then we just have to notice some things that are happening. What is happening here? And then we could just make some observations. Okay, something I notice is that the 3 points, 1, 2, 3, are no longer in quadrant 1. They are now in quadrant, mostly in quadrant 4. So it looks like they went from here to there, which means they're kind of reflecting over my pen from here to here, which is reflecting over the x-axis. So that's my first observation. Reflect over x-axis. And then I have to think about letters and numbers. So then I'm thinking to myself, that means my a value has to be a -1. And I hope that the numbers haven't changed. The second thing I've noticed, okay, if I do flip them, I notice that this point right in the middle, looks like this point, is being shifted up 2 units. Shift up 2 units. So if I was using my formula sheet, the one going up or down would be your d value, and that would be a +2. So if I have my rule, a times f of x, inside would be b times x minus c plus d. I have an a value. I don't have a b, so you can cross off the b. I don't have a c value. So you can just put all these numbers in front. So I have a negative, -1, or just negative, the function of f, and then plus 2. So my answer would be negative f of x plus 2. That was directly taken from your skills practice. And then question number 9. The equation of the polynomial p of x is given. The equation for the transformed function m of x in terms of p of x is also given. Show your work in box your answer. P of that we said is x cubed, and then m of x equals negative p x plus 5. So the first thing I'm going to notice is I have this thing on the outside. That is my a value. There's the b, and then plus d. So a value of -1, and then there's no d value. There's no b value because there's nothing to the left of x. So this would be a minus minus. So my c value is going to be -5. So c equals -5. My a value is -1. And then we were supposed to describe the transformation that's performed. So number 1, reflected over the x-axis. That's the a equals -1. It's supposed to be a -1. The second observation is c equals -5. And if you use your formula sheet, when c is less than 5, you actually do the opposite. You're going to go right. So this would be right 5 units. So that is my describing the transformation. Then it says write a specific equation for m of x. Well, how do you do that? So we talked about in class, well, m of x, let's just write m of x. M of x equals negative p x plus 5. And we talked about the p function. So p is here. That says x to the third. We're just going to write, think about this. Watch how I do this with parentheses. All of this right here is x to the third. X to the third. And what do we do with x to the third? We're going to have to put a subtraction sign on the child function, and then we're going to the left 5 units. Why did I write right? I can tell it. Remember, I was looking at my trick. Add to x, go west. So that means left 5. Sorry. Now, here it's telling us, instead of putting in a x value, for every x value, you're going to put in x plus 5. X plus 5. Okay? So if you get this equation, I'm probably going to give you probably 3.5 or 3.75. But you can actually simplify it. So what does this mean? You're going to have to write it out 3 times. And then just use your boxes. So let's see if I have the colors for this. I'm going to multiply these two. We did this in class. Actually, the last 3 questions were directly from your packets. Student edition or skills practice. X times x is x squared. X times 5 is 5x. X times 5 is 5x. 5 times 5 is 25. If I combine like terms, I get x squared. Let's write that. X squared plus 10x plus 25. So in orange. And then now what I have to do is I'm going to have to multiply this trinomial with 3 terms times this binomial. And in the very end, we're going to have to take the opposite of that. So let's draw a super long box. And then x squared plus 10x plus 25, and then x plus 5. And this is like the same math that we did up here in question number 6. So let's do it. X times x squared is adding the same, multiplying the same base, add the exponents. That's x times x times x, which is x cubed. X times 10x gives me 10x squared x times 25 is 25x. X squared times 5 is 5x squared. 5 times 10x is 50x. And 5 times 25 is 125. So I put it in here. Put a check. X cubed. These two check. Adding those together, 15x squared. These two, which would give us 75x, and then 125. And then the negative sign means you just switch all of the math operations. So the answer would be negative x cubed minus 15x squared. So I'm switching all the signs. Negative 75x minus 125 would be my answer. And let's count out the back side. So I have 2, 4, 6. That one's a 4, plus this one is a 4. This one's a 4. And then we said that this is a 2 and this one's a 4. So this would be 6. So I got 10, 20, 24 on the back side, not 16. And then, so the whole test is going to be out of 4. Good luck.
Math.
Say it again.
Our math.